We're going to combine 4.4 and 4.5 because 4.4 is rectangles, 4.5 is rhombuses and squares, so it kind of all goes together. A rectangle is a parallelogram with 90-degree angles. I assume most of you delete. Oh, not what I wanted to do. Most of you have seen, I mean, that's a terrible rectangle, but something that looks like this before. All rectangles, so the little blue circle, are parallelograms. They fit inside of parallelograms. They're a very special kind of parallelogram is basically what we say about them. Because they are parallelograms, they retain all the properties of parallelograms, so the opposite sides are still congruent, opposite angles are congruent. They're just more particular. Okay? So we have all of our previous rules about parallelograms, and now we know opposite angles. Opposite angles are right or 90 degrees, and diagonals are congruent. So this is just the picky habit, another extra rule about them. So we can play around with some of these rules. So this is a rectangle. I'm told I got a 50-degree down here. Follow the steps to find the value of x. So we can play around with this. I know that an angle should be 90 degrees total, so if this side's 50, this side's 40. And I like the rectangles because you can just keep playing with this. Since this is 50, these two should match. These are like a matching pair because these are the like smaller triangle. So this is also 50. If I wanted to keep going, I could say this side is 40 because they're making 90-degree angles together. But I don't even need that anymore. I want to try to get up here. Well, I have this triangle with the two 50s. I know triangles add up to 180 degrees, and I've used up 50 and 50, or 100, which means I only have 80 left. So this top quarter would be 80, and guess what? That's that matching pair idea, because the top up here, the same as the bottom, so this would have to be 80. So it's just ways you can play around with some of these angles. If you know it's a rectangle, use that. You know, same, different, same, different. You got that 90-degree stuff happening. If you want to prove, so you know something is a parallelogram, right? And you want to prove it's a rectangle, those converses, you need to show all the angles are 90 degrees, which really just means you need to show one angle is right. So you need to show one angle is right, because if that one angle is right, then the opposite angle is 90 as well, and then subtract from 180, you would get 90. So you really only need to show about one angle being 90 degrees. You also could just show the diagonals are congruent. Hey, we're not going to check with a protractor. That's just silly. The next shapes we're going to look at, the next one's a rhombus. A rhombus is a parallelogram with 4 equal sides. So it's like a slanted square. Again, all rhombi, they're all parallelograms, and only some parallelograms are rhombi. It's a special case of a parallelogram. Rhombi will always be quadrilaterals, and some quadrilaterals are rhombi. Same idea, since this is a parallelogram, the rules of parallelogram still apply to a rhombus. So here's all our properties of parallelograms. And what do I know now? I know all sides are congruent. I know adjacent sides are congruent, which kind of fits into the all sides are congruent. I'm not sure why they added that, but whatever. The diagonals are perpendicular to each other, which means 90 degrees. Okay, it's another way of saying right. So the middle, here's an example. These meet at 90 degrees. I know that's 90 in there. Diagonals Oh, diagonals bisect interior angles. Doo-doo-doo. So this angle here, whatever A is, if we said A is 40, this side would be 20 and this side would be 20. It's being bisected, the diagonal itself, because it's a rhombus. So we can do this problem. I want to find out x. Well, how would I go about doing that? Well, I can go to this perpendicular, right? I know this angle up here is 90. I know I have a triangle here. Triangles add to 180. So I could do x plus 14 plus 90 equal to 180 degrees. And now I would combine like terms. I get 2x equal to, oh, sorry, not equal to, plus shoot. Okay, I made it further down than I thought. Plus 104 equal to 180. Subtract. And I get 2x equal to 76. And finally, I would divide by 2, which would give me 38, I believe. Okay? So I can play around with some of these rules. If you want to prove something is a rhombus, you want to show all sides are congruent. You want to show adjacent sides are congruent. Or you want to show diagonals are perpendicular or 90 degrees towards each other. I'm so sorry. Or you want to show diagonals bisect the interior angles. Okay. Bisect. Finally, we have squares. Squares are rectangles with equal sides, or you can think of them as a rhombus with 90-degree angles. Square, and equal sides. Okay? All squares are rhombuses. Some rhombuses will be squares. All squares are rectangles. And some rectangles will be squares. Rhombi and squares are parallelogram. All of them. Everything's a parallelogram. And everything is a quadrilateral. Okay? So what happens with the square is it has just every property. So we're just going to fill in these columns with yes. This is a great place on the screen to like screenshot and look back at this page. So what we can do here actually, if something's true for a parallelogram, it's true for everything. So I could check this off. And we can do that with everything that is true for a parallelogram. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. That's true for everything. Okay? Squares are a type of rectangle. So everything that's true for a rectangle, you should mark off in your square category. So this is true because it's true for rectangle, true for rectangle. So now we need to go through and mark off what's true for rhombus. All angles are right. Rhombuses don't necessarily have right angles. All sides are congruent. That is true for a rhombus. Diagonals are congruent. That's not necessarily true for a rhombus, but the diagonals are perpendicular to each other. And diagonals bisect opposite angles. That's true for a rhombus. And guess what? If it's true for a rhombus, it's true for a square. So everything should be marked in the square category. Okay? I know it's a lot. We'll talk about this more.